Meanwhile, I'll talk about my experience for migration of Android application to iOS. Can you please just text in chat if you ever experienced working with KMP, or maybe you're already working with it, just for my familiarization. So, regarding our today's topic, initially I joined SoftServe, I believe, more than a year ago, and my first project was large retail. And the main feature of already existing iOS application was just inventorization and scanning of different items that are present in large stores. So today I'm going to go through our experience, and let's start from brief plan of our meeting. We will go just through familiarization of the project and other stages that my team and me faced during this implementation. So let's meet the team. As you can see, we are 5 here, plus Oleg. He was our Android architect for this project. And basically, I believe that almost everything can be done by great team. And I can honestly say that these guys and also management and also QA team were the best in my career. And basically, we were trying to achieve great results. And from another side, we had a team of specialists that were asking sometimes really strange questions. For example, why some, I don't know, functionality is not working, being tested on production, meanwhile we are developing a stage version, or why we cannot proceed with login if everything works terrible, but another part mentioned that everything is okay on our side, it's your fault. And we were trying somehow to communicate with these guys and deliver our best. So we started with really perfect choice. We merged our repos together. It was almost a terrible decision in our project development, because almost for all iOS PRs we were notified, and the same for another side. They were notified about our PRs. Reason actually for this was not sure if really correct, but we were trying to work together, and during 6 months we delivered great product. So we had 25 different Gradle models, convention plugins. We were trying clean architecture, for sure Kotlin and Compose. We had multiple tests, main features, brand new screenshot testing, and active aggressive PRs. Regarding models, everything was gathered into some kind of groups of models. Our main features were divided to small modules, and we had their DI, screens, tests, whatever. So basically, how we worked with our architecture. We had a bunch of stuff that is shared to multiple features. We had some kind of feature specific things that were placed in different models. Because our application was white labeled, for example, we had multiple clients, we used some kind of layer of abstraction and used DI to handle these abstractions. So basically, for each client, required dependencies were injected. Nothing specific mentioned to here, just a regular Android application. Regarding convention plugins, maybe you know this, maybe not. This was part that helped us to configure a lot of models. Well, actually 25 models, I believe not large number, but when you're creating such stuff dynamically, it's easier to handle everything with such dedicated parts of code that you can easily write and configure your your module depending on required plugin. So basically you can see here as an example how regular Android library convention plugin looks like and how linting convention plugin looks like. And as I mentioned before, here you can see our main architecture. We had a pure domain layer, we had data layer that was implementing a domain layer, we had separate network because our network strategy was kinda tricky. UI stuff with some core components, with themes, colors, etc., and resources and features. Basically, each feature contains its own currency model, other code that depends only on this feature, and everything, all features, were gathered in the final application, where all navigation was linked into our one navigation stack. Let's continue to our technologies. We used Compose and Compose Navigation because it's pretty new, pretty standard choice for now. Room for databases, retrofit, Google Filament for 3D rendering because we had a large feature that supposed to display where exact item is physically located. Also, we had Dagger 2 for dependency injection, but after some time, our architect helped us to migrate to Coin due to some architectural decisions. We had model view models, Coil as image loader, data store, Firebase, nothing special, just regular Android application. We were using, we had unit testing more and less of UI testing. I will explain this in a moment. For unit test, we were using mock. Basically, this is pretty great library. If you're writing unit test, you can use all power of Kotlin and DSL to write tests. Personally, it's my favorite choice for all personal and work projects. So if you haven't tried it, just have a look in it. Here we can see that we have some kind of flow test. Basically, it's some kind of test where we were testing specific flows. For example, we were able to mock web server with mock web server library. We had coin rules for mocking specific coin dependencies because not all dependencies were able to be used in regular testing, and compose test rule for testing our application. And here is, you can see just regular example of test that run through login and checks all possible scenarios. But because such tests were really hard for maintaining and really were dependent on emulator, we had small amount of UI tests and preferred more unit tests. So basically our features were parts of tabs. Sometimes each tab contained few features, just for your understanding how our modules were implemented here. And we used a lot of screenshot testing. Basically, this stuff is still in alpha, but for Compose, it's really great library. We're able to cover our components and see if some things were changed. For this library, I have only one warning. If you got to use it, just keep in mind that for Windows, Mac and Linux, we have different rendering logic, and sometimes screenshots might be different, some kind of alpha issue or something like that. You might use threshold here for proper tests. And this plugin helped us a lot to achieve and keep our components up to date, visible, and helped us in order to break such components during rapid development. And also active aggressive PRs. We all were a team, and we all are a team still, I believe. And we were doing a lot of great stuff. And during our communication and great advices, we were able to deliver fast and great code to our client. And yeah, sometimes I was too such toxic person. Our final mission was to release the first phase of this application development and pass SecOps certification. Basically, SecOps certification is some kind of scan when you're just producing a regular APK or bundle, giving to that company this APK or bundle. They're running some kind of static analysis, dynamic analysis, whatever stuff, and they're checking if there are no things broken like SSL pinning is missing, or maybe we have some kind of credentials in the code or other stuff. And basically, after such a great phase, we understood that our client want to fire us, and after final thought, we were supposed to migrate our application to Kotlin Multiplatform, just propose such stuff because client was not satisfied with current iOS situation because application was developed not with a great approach and had a lot of issues. And we just had such idea. But for Android application, everything was well. So a lot of people that were working from different teams, they were happy with our code base. So everything was okay. That's why we were sure that this idea might be great. And also we had colleagues, just joke time, that believe that committing secrets in Git is not a big deal, but it was really a big deal. And client accidentally say that, sorry, we have no money. We should reduce our cooperation or even finish it in the month or something like that. And during that time, business analytics and me were in USA with client, and we were a little bit shocked with such decision because our director was fired basically an hour ago and we were totally lost. That's why we were thinking if we can somehow rule the situation or if we can gain some kind of profit of our business trip to client, we should somehow action. So we decided with team to create some kind of POC that's supposed to show that see, you have great Android application with no bugs, everything works perfect, everything is great, and we can adapt this application to iOS, and you'll receive both platform working well, already tested, and you can just leave us as we can deliver you this product. So we agreed to try, and I picked this migration flow. More or less plan was simple, just pick all modules and module by module, migrate to Kotlin Multiplatform. Basically for domain it was pretty simple because as you know domain usually contains some kind of interfaces, use cases, and other stuff that is written in pure Kotlin. Still, we were using library local datetime that was replaced by Kotlin X datetime. Pretty easy migration. For network, it was a little bit trickier as we used retrofit. I know that um we have Torfit, something like Kotlin Multiplatform solution that can be easily adopted with retrofit, but it was not so stable during that time. So we migrated to Ktor, and also migration from JSON to Kotlin X realization. For Room, basically we received almost alpha support during that time. For Kotlin Multiplatform, we were happy about it because we can just try for now, and after a few months it's gonna be stable and everything should work without issues. And also data store was already KMP compatible. For UI, it was a little bit tricky as Compose multi-platform had basically some different versioning for now than regular Compose. And I supposed to migrate some components to better compose multi-platform stability, but because our team did great job and our components were perfectly suitable for I believe some kind of layering of screens of views, we achieved great result with this migration. All other stuff like view models and other UI components were already supportable with KMP, or they're supposed to be migrated to KMP side. Zero also do not have yet support for Kotlin multi-platform, so we got to create our own solution here. For navigation, we also received some alpha version of Compose Navigation multi-platform. Previously, I was thinking why it was frozen and why there are no updates for this version recently, and I understood only with the release of Navigation 3, because Navigation 3 goes can be supportable out of the box. And some solution for iOS uses Compose UI view controller. So basically it's a function that provides us UI view controller, and we can call some system APIs with it. So let's go through our implementation. First of all, we migrated our Android library convention plugin to Kotlin Multiplatform. As you can see here, we are applying proper plugin right now. We are configuring our targets. Basically, it's Android, it's iOS. Nothing special here if you already faced with Kotlin Multiplatform. Next one, we move to some kind of yeah. Just was thinking what I should say here. Yeah, next one. As you can see here, we have a little bit different way of configuring our source sets for Compose multi-platform, because we have such stuff as common main, so basically where all our dependencies that are Compose multi-platform compatible mentioned, and we have some platform specific implementation. Like here we have for, as you can see in common main from the left side, we have all our modules specified. So basically all our modules were Kotlin multi-platforms compatible. And for Android main, we were using some kind of Android Con extensions, some kind of KSP for Room and other stuff. For unit test, mainly our unit tests were placed in Android unit test source set, because Mock do not support yet work with Kotlin multi-platform. So basically nothing specific, we just need to remember that all common code should be placed in common main, all platform specific should be placed in platform specific source sets. Next one, like it's kind of small hack for exporting dependencies for iOS, because for iOS there is no such kind of API instruction that we usually use in Gradle development when all our dependencies are just transitionally added to our code, we should use such instruction as export. So it's gonna export your dependencies into your native iOS project. Without this instruction, you would be able only use code of included library that is built with Xcode. So basically we are picking something like shared UI or shared app and are gathering all data from this dependency directly to Xcode. So only that code should be present in application without these export functions. Next one, let's talk about tricks or hacks. First of all, you understand, if you're an Android developer, that almost all stuff is done with context. So we have some resource fetch, and we have some, I don't know, views creation and other stuff that is done by context. So we created this platform context stuff that for iOS just simple object, just stop. For Android, it's regular context. And we were using this to pass to our components wherever it's needed. And for local platform, yeah, and because we were working with Android, we were using providable composition locals to get this data. So basically, if usually what we were doing, we were using local context current in Compose, but for Kotlin Multiplatform, we wrote our own extension here and basically worked with it. And during first phases, we received kind of interesting feedback from our iOS side that they are not happy with our decision to work with KMP. Basically, just a regular feedback from iOS team that do not want to be replaced of Kotlin multi-platform usage. And we were okay with it because we understood that it's our decision and it's our possibility to stay longer with the client. Next one, wanna talk with the iOS dependencies. Basically, it's more painful stuff for Android and iOS developers too. Usually we have two ways of providing dependencies in Kotlin multi-platform. It's Synterop and Cocoa Pods. First, let's talk about Synterop. It's some kind of way when you're providing some specific definition files with really specific instruction inside it, and it generates kind of abstract functions or external functions that you might use in your code. So basically, it's some kind of definition example of what is here, boring SSL or something like that. Yeah, and it's kind of specific way of adding static libraries into your code, and you should really know and understand how all this stuff works. Second one is pretty easy. You're just using CocoaPods dependency. Inside it, you're adding required pod. Under the hood, Ruby does some magic. It fetches required components, just transform them into specific bindings, and you can use this code in your Kotlin multi-platform code base. Here you can see that it has specific package, and if we are using Firebase Analytics, we can later use these keys and these components in our Kotlin code base. Here's supposed to be some kind of weird joke about Xcode and CocoaPods, but I haven't found it, so gonna be just funny case. It was really annoying to use the first or second approach, so we decided to pick another one. Like we have coin under the hood still. We have Compose UI view controller. Basically, it's our menu controller that we are using for rendering our Compose application on iOS side. And we are passing all dependencies through it. So basically, we are not using uh, like we are still using DI here because we're loading these modules with coin, but we are not using other approaches. Why it was done so? Because in this case we can easily go with clean approach. For example, we can write desired methods, we can write desired classes. And here, for example, we have Android implementation of our analytics class. As you can see, under the hood, we are using our native library. And for iOS, we are implementing this on iOS side. So basically, we are using our Firebase Analytics interface, and without additional tools, we can just add our analytics, our Firebase Analytics with, I don't know, it might be Cocoa Pods, it might be Carnage or other like dependency tool, but we are using our Swift code to implement this interface. And we are passing it to our application. As you can see here, we have Swift code, we have our main controller that is instance of Compose UI view controller. So basically it's here. And yeah, here we are creating our native classes and how it looks like from final point of view. Basically for Android, we have our application, we have our main activity. In main activity, we are setting our main navigation that is shared for iOS for Android, as the same for iOS. Basically, this composable is called from previously mentioned Compose UI controller. Next one. I believe you already knew our good friend Android View. Basically, it's specific helper that allow us to create some instance of native regular Android View and use it in Compose. The same stuff is present for iOS side. We can use UIKit view for creating such components. Basically, as you can see, both the same, nothing special here. But because we had specific components in our project, we're supposed to use this approach to create unique composables that are using this platform view. Regarding migration to of our network stuff. Basically, if you haven't tried previously working with Ktor, it's more or less the same as retrofit. The only difference is in the way of handling configuration. For example, you can see here that we have interceptor that implements some kind of logic. The same stuff is done here for Ktor. Basically, a little bit different approach of working with configuration, but almost the same stuff. For DB approach, I was really happy to work with first alpha version of Room because they announced such stuff as bundled SQLite driver. As you know, for iOS and for Android, we are using SQLite under the hood. And for Android especially, it's kind of tricky case when you have some kind of old version of SQLite installed on your device and you're writing some kind of new instructions in your SQL query. And just to prevent this stuff. For example, if you want to use new version on older devices, you can use bundled SQLite driver to install directly onto your application. This way of intercepting new versions of database. And we use this approach just to easily create platform specific modules and use our database. So basically it was only change for database layer here. As I mentioned previously, sometimes we were using such stuff as local UI controller. You know that for mainly all operations that are connected to navigation or maybe sharing or interactions, we should use view controllers on iOS side. And with this approach, you can see here how it looks. We have some kind of protocol implemented. In this case, it's a document picker. We are creating this UI document picker view controller, specifying some kind of required arguments, and using instance of local UI view controller to get current view controller and launch our document picker. So basically it's a way of working with outer world for Compose. For navigation, we just added only a specific handling of parameters between destinations, because we must specify only types that are bundle compatible in navigation. So that's why we used kind of hack to serialize almost any type. I know that with the latest versions, this approach is not applicable because JetBrains migrated to uh, from bundles to stores or something like that. And right now you should work with another structure to store this stuff. But basically, I believe it should be present also in new navigation. If you face this, guys, please send comment in chat because I haven't tried this yet. And let's see how we can interrupt with Swift code. Previously, we have seen as an example how we can work with document pickers. Here's a regular example, just show fingerprint lock. For Android, it's pretty simple. We have our platform instance, as you remember, it's context on Android. In this case, I can cast it to fragment activity because I know that it's fragment activity. We are using biometric prompt, adding some parameters and calling authenticate. How it looks like from iOS side. We should check if our device can work with local authentication with biometric, and we are going to check if we have some kind of biometric supported. So basically it's iOS version of the code. For Android, we're gonna write it, and it should be more or less the same. Basically, we have pointer here to our error. We are checking if our device can evaluate required policy. We are mapping to our internal classes iOS constants. That's it. Basically, nothing special, and it's the way how it looked like from a navigation point of view. So this code is transformed to this one. Almost the same. The only difference that usually for iOS you are using dot and short version of enums or other components. Here you must specify full key for it. For resources, we had multiple approaches because we really had multiple ways of things that we should render. We had SVGs, we had Android native PNGs, we had Android vector drawables, and we were using Compose Multiplatform and Mocker sources for these scenarios. Also, some things like arrays were supported in one library. Some components were not supported. So basically, it was kind of mess for us, but we had to try and to deliver this application to iOS world. Next one, we were using um, screenshot testing, as I mentioned before, and how we migrated this stuff to Compose multi-platform. Basically, when you're including Compose multi-platform module, you're able to use already included dependencies that are starting from Compose. There you can have already predefined versions of multiple components, and one component is UI Toolkit Preview. Basically, it's that preview that is used in regular Android project, and its place in common main. That's how it looks like. So just a regular function. We have some composition locals for overriding some providers, and why it's useful. Here you can see that I had project with 43 different themes, just an example. And for us, it's really great option to have somehow render these items without direct launching or swapping manually. In this case, we are using preview parameter provider, such specific class that help us to provide multiple instances of specific type and render as much items as this preview parameter provider produces. Under the hood, we have iFork sequence, and basically this sequence is responsible for this emission. Great option if you have multiple themes in your application. And basically we did it. We did a great job. Our release was really successful after struggling with login issues that were not on our side, but everyone was sure that it was on our side. We were happy to announce that first version of the app was released, and we were really happy with it. We also added some kind of Easter egg for different seasons. We had different UI of our login page, and it was only visible for our QAs. That's why no one from client team face this. By the way, if you want to determine if your application is in debug mode for Android, I know that you already use build config debug. For iOS, we have platform.isDebug binary. So that's why that's how I displayed this preview. And also we produced desktop version. As you can see here, it's Android version, here it's iOS, and in the center we have desktop version. It was some kind of surprise for a client. And surprise for me because I was responsible for this polishing. It was kind of tricky to migrate everything for desktop, but it was kind of challenging and interesting experience. Thank you, Oleg, that you mentioned that we're gonna display this version too. And I become senior tech lead KMP migrator in 1 week. And yeah, you want a joke? I believed you already understood that finally our client decided to move on. And it was kind of surprising for us because we did a lot of stuff and we were really disappointed a little bit. Also, final nail was message of head of engineering that they're gonna to expand their own team. So basically, all our job was done for future generations. and I hope that everything gonna be good with it. But I'm really happy that was part of such great team. And now to some kind of thoughts. You gonna try KMP if your team can work with it. Basically, it's a great case when you can produce two on even more platforms in a single code base. And for me, it's always kind of great moment when you're trying to launch an application and it works perfectly for iOS and Android. Still, there's some kind of platform differences, and it kind of helps you to grow as a mobile engineer. Next one, if you're picking new projects, kind of simple thought. If you're creating new project from scratch, it's really easier to develop it from scratch and implement everything from scratch, kind of doing migration after a few months, because all this migration took something like months or something like that for our team. Also, if you wanna work with multiple platforms, kind of simple thought, if you are developing only for one platform, it might be not really great choice here, but if you want, you can try. Next one, if you have a lot of logic that is shared between platforms. I know that almost for all senior colleagues, when you're developing some kind of new feature that is already developed by our other platform, you're just opening that code and doing some kind of migration on your platform code, because usually application has the same logic for both platforms. Next option, if you want to try Jetpack's Compose multi-platform, right now it supports web. You can work with desktop, kind of great option if you want some kind of shared code. And if you know both platforms, for example, for me it's perfect choice. And right now I'm developing a bunch of libraries with Kotlin Multiplatform because I adore working and digging into both platform code. And for me, it's just a great option here. Next one, when you might skip Kotlin multi-platform usage. Uh, well, I believe this slide might be a little bit changed because right now Compose multi-platform is more less great if you're talking about UI performance. Plus JetBrains teams put a lot of efforts on iOS stabilization, and I believe in future we're gonna see a lot of improvements for iOS. But basically sometimes, especially for iOS side, we're gonna see some issues with rendering, with UI or other things. It's kind of regular stuff. Even me faced few times some kind of weird issues while working with Compose multi-platform. Next one point, if your application is really mature or you have platform specific app, it's kind of tricky thing because sometimes if you must have fully native performance or you're working with kind of specific things that might affect system APIs or application performance, it might be not great option to use KMP in your project. And second, also, as you've seen from 1 hour slide, our iOS engineer was not really happy that we were working with KMP during our implementation. That's because he was proficient in Swift and Objective-C, and basically he had no experience with Kotlin. It might be kind of a really blocker for your team, or if your application is written in pure Java, because here Kotlin knowledge is mandatory. Yeah, we already talked about native performance, only single target also mentioned. And kind of case when you have a lot of third-party libraries. The reason of this is under its implementation, because if you have some kind of alternatives for both platform, it might work, because as you already seen, we used expect actual mechanism to write interfaces that have some abstract methods, and as implementations we were using native APIs, and for example we can use libraries. But if libraries are kind of different, for example, as I believe it's Dropbox that I recently seen, they have totally different APIs, and I believe iOS and Android teams in Dropbox never seen each other, because in other case I do not understand how these libraries can be so different. So basically, that's it. My final thought is, if you haven't tried yet, just check how this works. I'm more mainly Kotlin Multiplatform fan, and I'm trying to spread my knowledge between colleagues in the company and also on LinkedIn, and during my personal projects, I'm using it a lot. Personally, it's my favorite choice for cross-platform. I have different reasons to talk about this, but I would rather stay with Kotlin multi-platform rather than different multi-platform tools, except native. I also adore native development. And that's it. If you have any questions, you can write this or ask in chat or ping me later. No.